Everyone. Hope you guys are having a phenomenal Thursday. Before I forget, let me just remind you guys that tomorrow you're going to need to bring your Chromebooks. Make sure they're nice and charged because you guys will be playing a game on there. Okay, I'll try to remind you guys at the end of the lesson, but again, don't forget to bring your Chromebooks tomorrow. Today we're going to spend our time though talking about areas of pyramids and cones. We'll do our surface area and our lateral areas just like we did with our prisms and our cylinders. Okay, first let's go ahead and even talk about what a pyramid is. So a pyramid is a polyhedron, and remember that's just very fancy for saying something that's three-dimensional, in which one of the faces, one and only one, and this is also going to be our base, can be any polygon. So our base, for example, like the one below, could be a hexagon, it could be a square, it could be truly any polygon that we've studied, but all of the other faces have to be triangles. Okay, so those lateral faces are going to be triangles. Unlike the faces that were in our prisms, which most of those happen to be rectangles. So this time our lateral faces are going to be triangles, and all of those triangles are going to meet at a common point here at the top, known as the vertex. Okay, so that's the definition of a pyramid. Again, it has one base. This one happens to be a hexagonal base. And then all of the lateral faces are going to go ahead and be triangles. Now, pyramids are interesting because they have two different types of heights. They first have the one that is the altitude. Okay, and we know that from many times studying this, the altitude is going to go ahead and be perpendicular segment that goes from the vertex to the base. Okay, so if I look above at my diagram, that segment right there is my altitude. Now, when you're looking at your formula sheet, that altitude is what we are going to go ahead and call the height of the pyramid. Oops, sorry about that, guys. In the height, we'll use a capital H on our formula sheet. So that blue line that I highlighted up there is going to go ahead and be the height of your pyramid. Now, a regular pyramid is a pyramid whose base is a regular polygon. And these are the ones that we're going to focus on in this chapter. So for example, your base wouldn't be a rectangle, it would be a square instead, or it would be a regular hexagon, so that we can use the formula 1/2 the apothem times the perimeters. When your base is regular, it also does something pretty cool to those triangles, and each of the triangles will be isosceles triangles. So remember that in an isosceles triangle, at least two of the sides are going to be congruent to each other. Now, as I said, pyramids are interesting because they actually have two different types of heights. We have this blue line right here, which we're going to indicate with a capital H. And there's also something called the slant height. Okay, this slant height is represented using a cursive lowercase l. And this is actually going to go ahead and be the height of one of your faces, aka it's going to be the altitude of one of those triangles. So we have in this diagram, and I'll pull up one more to try to make it a little bit more clear. We have the height of the pyramid, which is going to go from the vertex perpendicular to the base. And then we also have the slant height, okay, which is this one. And that's actually the height of one of those lateral faces. So again, let me try to see if I can find a better picture here for you guys. I think this is a little bit more representative. Again, this height here is what we're going to represent with a capital H on our formula sheet. And this slant height, which is actually the height of the lateral face or the height of the triangle, we're going to represent with a cursive L. So those are our two different types of heights, and that's pretty much the only new thing when we're coming to pyramids here as opposed to our prisms from earlier this week. We are still, just like we did earlier this week, going to find our lateral area, which in this case would just be the area of all of the triangles together. And then we also are going to go ahead and find our surface area. But unlike with our prisms, we actually only have to find one base in our pyramids, and that will be reflected in our formulas that we see on our formula sheet. Okay, so let's go ahead and unfold one of these shapes, also called finding the net of it. If I were to take this prism right here. Okay, so it is a square base. It has the 4 lateral sides. And unfolded, it would look something like this. And I think you guys could agree with me that if I go ahead and call the base of this triangle S, and I call that lateral height there, that L, you guys know the formula from your formula sheet of a triangle is just 1/2 the base times the height. But I don't have just one triangle. I have 1, 2, 3, 4. So if I were to actually try to find the whole lateral area of this pyramid, I'm going to have 4 of those triangles. Okay. Now, this actually works out really well because that 4 and that S, if I were to go ahead and take 1S, 2, well, let me get a different color, 1S, 2S, 3S, 4S. 4 S's just make the perimeter of that base. So your quick formula for finding the lateral area of a pyramid is 1/2 the perimeter times the side height. So that'll give you your lateral area instead of finding the area of each triangle separately. And then to find your surface area, the only thing that I need to do is add on that yellow base. So I'm going to go ahead and take the lateral area, all 4 of those triangles, and add on the area of one of your bases. And this is the formula that you'll see on your formula sheet. Now keep in mind, big B is the area of the base. And your base could be anything. It could be anything from the top of that formula sheet. It could be a square. It could technically be a triangle. It could be an octagon, right? 1/2 the apothem times the perimeter, etc. Okay, so you have many options to look above to find the area of the base. Let's go ahead and do one example here. So I have a pyramid. I know my lateral area formula is 1/2 the perimeter times that slanted height. And one of the things that I notice right away is that I'm able to easily find my perimeter, but not so much that slant height. Be really careful because technically it's not even drawn in here yet. Let me go ahead and draw it in. So it goes from the vertex, perpendicular to the side. So that is technically my slant height. This 13 right here is representing the lateral edge. Now, because it is an isosceles triangle and it does go perpendicular to the base, that means it is going to go ahead and bisect that base. I'm attempting to find that slant height. Now you have a few options. Pythagoras, he's awesome. Or your other option is maybe you remember some of those Pythagorean triples. There is a 5, 13 triple. Hopefully some of you guys are thinking in your head right now. 12. Okay, so that would go ahead and be my slant height right there of 12. Now I think I'm ready to finally find my lateral area, which remember is just going to be the area of all 4 of those triangles combined together. So I have 1/2 the perimeter of the base. So I have 10, 10, 10, and 10. And I just found that slanted height of 12. Well, half of 40 is 20. 20 times 12 is 240. And again, it's lateral area, so we're looking at units squared. For my surface area, my formula told me that I'm going to take that lateral area, and because it is a pyramid, I'm only going to add on one base. Got big B stands for the area of that base. I can see right now that the area of that base is a square, and so I know for a square, it's just going to be base times height, or 10 times 10. So I'm going to take my lateral area and add on 100. So my total surface area is going to be 340 units. All right, I'm going to go ahead and stop here. Here are your instructions. For example number 2, I would like you guys to work with your tables. I would like you to give me an exact lateral and surface area. So that means no decimals. We want radicals, etc., etc. for problem number 2. And then finally in problem number 3, this is the actual dimensions of the Great Pyramid of Egypt. There's some pretty big numbers in here, and unfortunately they don't work out very nicely. So on problem number 3, let's go ahead and round to the 100th place. Okay, so again, why don't you guys work on problem number 2 and problem number 3 with your tables, and when we reconvene, I will go ahead and show you guys the. All right, hopefully you've had some ample time to work on those 2 problems. If not, feel free to freeze me a little bit longer. But here are my solutions to these 2 problems. So I was actually given the slant height in problem number 2, which was awesome. And the only other thing that I knew was my perimeter. So I had 6 and 6 and 6 and 6 and 6 and 6. And so in the end, I ended up getting a lateral area of 162 inches squared, a nice number. But then I need to add in the area of one of the bases. And I noticed my base happened to be a hexagon. So I look back at my top of my formula sheet. My hexagon is going to be 1/2 the apothem times the perimeter. My apothem was 3√3. My perimeter was still 36. Now, here is my final surface area. Unfortunately, those are not like terms, so you cannot actually add them together. So 162 plus 54√3. All right, and then last but not least, we have our Great Pyramid of Egypt here. And again, these are the actual dimensions. The most challenging part about pyramids in general is you might not be given the information you need. Like perhaps you might not be given the regular height, or you might not be given the slant height. So in those situations, you are going to have to use the Pythagorean theorem or Pythagorean triples to go ahead and find out that information. Unfortunately, in this one, I didn't have that green line, that slant height. I did know, however, that my entire base here was 756. And I know that my height or my altitude that's going to drop down is going to go to the center. So 756 divided by 2 gave me that 378. Once I had that information, I went ahead and did my Pythagorean theorem down here. Now notice, if you didn't get the exact answers that I got, it's probably because you rounded that 611.76 too early. Please leave that in your calculator as you're working. My perimeter was 756, 756, or AK 4 times 756. My slant height I used here. And so your final, oops, sorry about that, guys. Your final area for your lateral height, or sorry, lateral area should have been 924,974.57 feet squared. Ooh, 2 mistakes. Oh, Miss Javin. All right, and then we still, for my surface area, need to add on that base. The base was a square. I look in my formula sheet. I know that a square is going to just be your base times your height, so I multiplied those together. I added it to my lateral area, and in the end, your total surface area, so all 4 triangles plus the base on the bottom, should have been 1,496,517.12 feet squared. All right, I'm going to go ahead and start a new video, and we'll go on to the cones in just a second.